Alright guys, we're on page 23 of your student journal. Working on Math 3, section 2.1, parent functions and transformations. So what are the characteristics of some of the basic parent functions? Graphs of 4 basic parent functions are shown below. Classify each function as linear, absolute value, quadratic, exponential. Justify your reasoning. So I'm not sure with what you know best, but I would just go in whatever order you are most familiar with, right? So for instance, these are the 4 graphs. I think linear should be the most memorable because it's just a line, right? So we can go ahead and go from linear, boom. What else? Absolute value. I think that one is less common for you to know off the top of your head, so maybe we'll process of elimination that. Quadratic should be a little more known as well. And then I guess between the two, yeah, exponential and absolute value kind of 50-50 in terms of what you might remember. So absolute value is one that looks like this. Oops, it's kind of ugly. Yeah, whatever. I mean, to do that again. It's the one with the straight lines. Jeez, really ugly. Yeah, but that one's absolute value. And then exponential is something like, 2 to the x power. That's just an example. It's just really just like a to the x power, where x is in the exponent, and that's why it's exponential. So depending on what you know best, you will eventually get to that absolute value is this one, and exponential is the other one. Yeah. So that's it for the matching. Justify your reasoning. Quadratics, 1 squared is like 1, and then negative 1 squared is positive 1, so that's kind of obvious. Linear, the basic y equals x, like also it's a straight line. And then absolute value and exponentials I kind of already talked about. If you forgot, absolute value is when it just makes it positive only. So if I plug in 1, I get 1. And then if I plug in negative 1, I get 1 still. Which you might look at that and be like, oh, I said the same thing for quadratic, but what's the difference? That's for you to think about in terms of, like, go ahead and plug in 2 then, right? And negative 2, I guess. So let's clear this. All right. I have to do it manually later. Oh, I can go to the next page. Sweet. Okay. So graphs of 4 basic parent functions that you will study later in this course are shown below. So in that case, I actually think I will leave this, and you can take a look, and I'll explain some, but I'm not going to match up for you. So square roots are square roots, cubic roots, or sorry, cube roots. So an example of a cube root might be like the cube root of 8 is 2, because 2 times 2 times 2 makes 8. Yeah. And the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2. Cube means, in this sense, or in this example, 3 times, right? Cubed. Cubics. And then reciprocal, which actually I'm not even sure. Can't remember when we're going to study reciprocals in this class. Okay, so yeah, this is matching for these 4 functions, and I will not do it for you. In your own words, write the meaning of each vocabulary term. So I highly recommend. I kind of hate the way that they do this. The order that they do this, and they give you this vocabulary, but you don't even know what you're using it for. So actually, we will get there, and you will use the student journal, or sorry, the textbook, you basically, just like a history textbook, right? Like you look for the bolds and the highlights, and that's where the information is, or some of the key information rather. So we're gonna cover these vocab words later, when we actually need to know what the point is of knowing them. Parent functions. So this is kind of like the starting point, right? So the constant is a straight line, y equals 1. Linear is, or sorry, I should say f of x equals x. So if you're thinking about like t-charts, then yeah, very, very similar to just x and y, right? Absolute value, I explained. Quadratics, also explained. So yeah, there you go. So we're gonna be looking at functions that have the same appearance, but are modified, right? And we call them parent because the modified ones come from these basic ones. But this is kind of like our starting point, I guess I would say. So identify the function family to which f belongs. Compare the graph of f to the graph of its parent function. Okay, so this comparing bit is where we're going to need some of that vocabulary, right? Because we need the appropriate links to say what's happening compared to the parent function. And then also identify the function family to which f belongs. So taking a look at this should be kind of obvious, right? Which function out of these four number 1 is. And I'm saying it like I haven't said it yet because I want you to think about, oh, which one is it? And it's actually linear. Hopefully that was obvious. So we'll go ahead and fill it in. Linear. Compare the graph of f to the graph of its parent function. So the parent function is, boom, something like that. Probably should have started over here. Yeah. So looking at this, sorry, pretend that's a straight line. The slope, for one thing, right, is negative. It's facing in the opposite direction, right? This is going up and this one's going down. We have a different slope as well, right? When we have y equals x, it's just a slope of 1, up 1 over 1, up 1 over 1. This is negative 1/4, so it's down 1 and over 4. And then lastly, we have this plus 8, which changes the y-intercept. That's a lot of different changes, right? And we don't necessarily have the vocabulary to describe that. So let's take a look. So transformation changes this size, shape, position, or orientation of a graph. Whenever you guys write, whenever you copy definitions or write down definitions of Word, I highly recommend doing it in your own words, right? Because if you copy this, you might have no clue what it means, right? If you're just copying the book definition. So a transformation changes the size, shape, position, or orientation of a graph. I think that does a pretty good job of, explaining it as it is. But yeah, maybe for you it would be different. So again, this is for the vocab on this page now. A translation is a transformation that shifts a graph horizontally, right? So in this case, I would still say horizontally, and I would encourage you to, but if you literally forget what that means, I would just say side to side and or vertically, so up and down, but does not change its size, shape, or orientation. So it looks exactly the same, but it either moves left and right or up and down. So in this case, we have a plus 8, right? This minus 4 is a vertical translation 4 units down. If it's a vertical translation 4 units down, what do you think this means? Right, starting here. And that's a vertical translation 8 units up. Our reflection is a transformation that flips a graph over a line called the line of reflection. Our reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line. All that to say, in this case, we do have a reflection because we went from going up to going down. So this is a reflection. Specifically, an x-axis reflection. Although when you're dealing with lines, linear, it actually, I don't think it matters. Yeah. For like other function, it gets more complicated that you do need to know which axis. So let's just specify and start off by saying this is an x-axis reflection. Next. Another way to transform the graph of a function is to multiply all the y coordinates by the same positive factor. So in this case, we've already dealt with the 8. We've dealt with the negative. That's what causes the reflection. And then we have to deal with this 1 over 4. When the factor is greater than 1, the transformation is a vertical stretch. So is 1/4 greater than 1? No. When the factor is greater than 0 and less than 1, so 1/4 is greater than 0 and less than 1, it is a vertical shrink. So to summarize, we have vertical translation 8 units up, reflection over the x-axis, and then a vertical shrink. Boom. So that's that. Now we'll speed it up a little bit. So this is a constant, and the original constant, and again, this is just literally looking at, like, your book should be open, so, right, like, you should be seeing this, but for me, it's kind of a hassle to scroll up and down, but to show you. So this is the constant, and the constant is f of x equals 1, or the parent function of the constant is f of x equals 1, but this is -3. So if I started off here, then what's my, what's the difference, right? And in this case, just move down by 4, a vertical translation, 4 units down. And this is a constant from the family of constants. Okay, so this is absolute value, and this one's, this is the absolute value. We don't have any pluses or minuses anywhere, so we don't have to worry about translations. We do have a 5 right here, and think about which one that means if it's 5. All right, I'm going to leave that for you. When the factor is greater than 1, the transformation is a vertical stretch. When the factor is greater than 0 and less than 1, it is a vertical shrink. So, yeah, think about that. Is 5 greater than 1, or is it greater than 0 and less than 1? This one, so we actually have, so see, this kills me. They don't even have, it's a combination of transformations, right? Because we have like multiple things going on, but it doesn't tell you, yeah, it doesn't go over, what's it called? A horizontal translation, but whatever. We could still look at it and, diagnose it, because you know that this is the original, right? Sorry, that's kind of ugly, but you know the shape, and I didn't actually even, I didn't graph the points accurately. I'm just showing you, like, you know the general shape. So this is x squared. So looking at this, like, there's no reflection, right? And there's no negative here, and there's no shrink or stretch factor. And so really all we have to do is look at the -1 and the +4. And look at how that impacts, like, where we're going. So from the original, the parent function, my vertex is now here.
Is that my mouse?
Yeah. And so describe that, right? Which direction did the vertex move in? Right, move to the right and moved up. And describe how many units it moved in each direction. Okay. So I'm going to do 2 of these, just so you get a sense, and then you can do the rest. So let's do this one. So, sorry, it says graph the function and its parent function, then describe the transformation. So you could definitely use a t-chart. If you have a graphing calculator, you could do that too. Then describe the transformation. So we're going to graph, and then we're going to use our words a little bit. This is linear, so it's simple. This is constant, so it's also very simple. Absolute value. Okay, let's do an absolute value one. So you already know the parent function looks like this. If you need to make a t-chart, that's fine for the parent function. Yeah, like square, or sorry, absolute value of x. Right? Plug in 8, get 8. Plug in -8, get 8. Plug in 0, get 0. Just like connect those. But then we have a +1. So looking at our previous stuff, we know that this +1 makes it a vertical translation 1 unit up. And so I will do that. I will just go up by literally 1. So you should be careful of units, right? Because this is up to, like, or the units go by 2s. And so if I want to go up 1, it should be just like this. Like right between, right? And then the slope is the same. Everything else is the same. So it might look like that. And then it might look like just half a box, 1 unit above, right? So I know my lines aren't perfectly straight, but you know, you get the point. Describe the transformation. I already said it. It's a vertical translation 1 unit up. And let's do, so this is fairly simple. It's right here, vertical stretch or shrink. Okay, this one is also vertical stretch or shrink. Okay, so let's do this one, 8. So you know that, sorry, so these are by 2, so 1, 1, 2, 2, 4, -2, 4, and -1, 1. So just so my drawing's a little more oh, dang it. Just so my drawing's a little more accurate than I made the last one. Okay. Sorry, I mean, I'm working with a mouse, so just kind of bear with me. This is the parent function. And the actual function, sorry. It's really hard for me to draw these lines straight, sorry. So let's plug in, like, I guess we'll just plug in -1, 0, and 1, so you have a general sense of the shape. So plug in -1, so negative, sorry, pretend that's a parentheses. So -1 squared. So we'll do the -1 squared first. So -1 times -1 is +1. So I have a negative outside the parentheses of a +1, which is -1. And then 0 is just going to end up being 0. And then 1 is going to end up being the same. It's -1. And so this will be the same shape but reflected, right? Oh man. Okay, I'm kind of having a hassle, so I'm going to leave drawing the... Oh, yeah, you draw a nicer one than me. So ugly. So describe the transformation. So this is a reflection over the x-axis. All right, so that's it for parent functions and transformations. We'll be studying more transformations next section. But go ahead and complete the rest, and let me know if you have any questions. Be sure to refer to your textbook if you're having any trouble, or just rewinding this video, or ask me any questions.